In the words of Francis Bacon, if a man's wit be wandering, let him study the mathematics. Now let us discuss about prime numbers. Prime number. A number is called a prime number if it has only two factors, 1 and itself. Let me write natural numbers. We have natural numbers 1, 2, 3, 4 and so on. We have natural numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and so on. These are the natural numbers. We can divide these natural numbers into three categories. One is prime, other composite, and one is neither prime nor composite. As we discussed, prime numbers which have only two factors, 1 and itself, are called prime numbers. Now I am writing these numbers and factors. Number and factor. I am writing a number and factor. Factors. Number one has only two factors, only one factor, 1. 1 can be written as 1 into 1. 2 can be written as 1 into 2. So 1 and 2 are the factors of 2. Next, 3. It's natural number 3. 3 can be written as 1 into 3. So 1 and 3 are the factors of 3. Next, 4. 4 can be written as 1 into 4, 2 into 2. So factors of 4 are 1, 2, 4. Next, 5. 5 can be written as 1 into 5. So 1 and 5 are the factors of 5. 6 can be written as 1 into 6 and 2 into 3. So 1, 2, 3, 6 are the factors of 6. 7 has only two factors, 1 and 7. 8 has only two. It can be written as 1 into 8, 2 into 4. So 1, 2, 4, 8 are the factors of 8. Next, 9. 9 can be written as 1 into 9, 3 into 3. So 1, 3, 9 are the factors of 9. So by observing the number of factors, we can decide a particular number is a prime number or composite number, or neither prime nor composite. Numbers which have more than two different factors are called composite numbers. One has only one factor, that is 1. So one is neither prime nor composite. Whereas 2 has only two factors, 1 and 2. So 2 comes under prime numbers. Prime numbers. Prime numbers. 2 comes under prime numbers. Whereas 3 has only two factors, 1 and itself. So 3 comes under prime numbers. 3 is a prime number. 4 has not only 1 and itself, it has some other factor 2. So it comes under composite. Composite numbers. 4 comes under composite. 4 is a composite number. Now 5 has only two factors, 1 and itself, so it is a prime number. 6 has not only 1 and itself, it has some other factors, 2 and 3. So 6 is a composite number. Whereas 7 is a prime number. 8 is a composite number, 9 is a composite number, 9 is a composite number. Why? Because 9 not only 1 or 9, it has other factor 3. So 9 is a composite number, 10 is a composite number, 11 is a prime number. What about 1? 1 is neither prime nor composite. So 1 is neither prime nor composite. Neither prime nor composite. One comes under this category. 1 is neither prime nor composite, whereas 2, 3, 5, 7, 11 these are prime numbers. 4, 6, 8, 10 and so on, these are composite numbers. Now we can make another observation by this table. See, 2 has a prime factor 2. 3 has a prime factor 3. 4 has a prime factor 2. 5 has a prime factor 5. 6 has a prime factors 2 and 3. 7 has a prime factor 7. 8 has a prime factor 2. 9 has a prime factor 3. So from this observation, a number greater than 1, every number greater than 1 has a prime factor. Every number greater than 1 has at least one prime factor. So we can write that fact. Every number greater than 1 has a prime factor. Every number greater than 1 has a prime factor. Now let us know about some more points about prime numbers. We have a question in our mind whether number of primes are finite or infinite. Primes, we have prime numbers, primes 1, 2, 3, 5, 7, 11, 13 and so on. Whether the number of primes are finite or infinite. Euclid proved that number of primes are infinite in the book 9 of Elements. Euclid proved that the number of primes are infinite in the book 9 of Elements. So number of primes are infinite. We can come to know by simple observation. Let us go. We have prime numbers 2, 3, 5, 7. I am writing the prime numbers from prime numbers. Two, 3, 5, 7, 11, 13, 17 and so on. So I wrote prime numbers. These prime numbers we can say as P1, P2, P3, P4, P5, like that we can say. Okay. Here these prime numbers, there is a question whether number of primes are finite or infinite. By simple observation we can come to know. It is very clear 2 is prime. 2, 3 are primes. Two is a prime, 3 is a prime. Are the 2, 3 generate any prime number? See, 2 into 3 plus 1. 2, 3 is 6 plus 1, 7. 7 is a prime. 7 is a prime number. I am taking 3 prime numbers, 2, 3, 5. 2 into 3 into 5 plus 1. 2 5 is 10, 10 3 is 30. 30 plus 1, 31. 31 is prime. I am taking prime numbers 2, 3, 5, 7. 2 into 3 into 5 into 7 plus 1. 3 7 is 21. 2 5 is 10. 21 is 10. 2 10 plus 1. 211 is 211 is a prime number. I am taking another prime number 11 also. 2 into 3 into 5 into 7 into 11 plus 1. 3 7s 21, 21 11s. 21 11s 1 2 1 2, so 231. 231 2 5 is 10. 231 into 10 2310 plus 1 2311. 2311 is prime. One more observation. Next prime 13 also I will consider. 2 into 3 into 5 into 7 into 11 into 13 plus 1. Here 3 7s 21, 21 11s 231, 231 into 30. 231 into 30. 3 1s 3, 3 3 is 9, 3 2 6, 1 1 1, 1 3 3, 1 2 2. So 3 10 1 10 3. See 2 5s are 10, so 30,030. Here plus 1 30,000 30,031. 30,031 is prime. From this observation, we can come to know primes generate primes. Primes generate primes. So number of primes are infinite. Number of primes are infinite. Euclid proved number of primes are infinite in the book 9 of Elements. Now let us prove this fact. Now let us prove this theorem. Prove that there are infinitely many prime numbers. Prove that there are infinitely many primes. I am going to prove it in contradiction method. In the contradiction method, we go quite opposite to the given statement. After some sequence of steps, we may arrive to contradiction. Suppose we have to prove number of primes are infinite. Let us go with quite opposite statement. Suppose assume number of primes are finite. Suppose assume that the number of primes are finite. Say let primes be, let those primes be P1 and comma P2 comma P3 and so on Pn. Those finite prime numbers let us take as P1, P2, P3 and so on Pn. There are only prime numbers are there up to Pn. Let us consider like that. See, now I am considering, let us consider a number. Let us consider a number n equal to P1 into P2 into P3 into and so on Pn. The product I am taking. Those product I am taking. P1 into P2 into P3 into and so on Pn plus 1. N is a number which is nothing but P1 into P2 into P3 into so on Pn plus 1. And now this product P1 into P2 into P3 and so on Pn, it transposed to the left side. It become minus P1 into P2 into P3 and so on Pn. So n minus P1 into P2 into P3 and so on Pn into Pn equal to 1. Take it as the equation 1. Here n minus P1 into P2 into P3 and so on Pn equal to 1. Here LHS in left hand side, n minus P1 into P2 into P3 and so on Pn there. Whereas right side RHS is 1. Now let me n is a natural number. We know the fact that is every natural number greater than 1 has a prime factor. We know as we know every number greater than 1 has a prime factor. It is very clear n is greater than 1, n is greater than 1, as n greater than 1, n must have a prime factor, some prime factor. Let n has a prime factor pi, where I is in between 1 and n. I 1 less than or equal to I less than or equal to n. Let us take n has a prime factor pi, where 1 less than or equal to I less than or equal to n. So now pi is a factor of n. That is nothing but and also it is very clear that as I is in between 1 and n, including 1 and n, so pi, this product P1 into P2 into P3 and so on Pn is exactly divisible by pi. Also this product P1 into P2 into P3 and so on into Pn is exactly divisible by pi. N is divisible by pi. This product P1 into P2 into P3 and so on Pn is divisible by pi. So this difference n minus P1 into P2 into P3 and so on Pn should be divisible by Pn. Therefore n minus P1 into P2 into P3 into and so on Pn into Pn is exactly divisible by Pn. Now observe this equation. In this equation LHS n minus P1 into P2 into P3 and so on Pn is divisible by Pa. So RHS 1 should be divisible by Pa. Therefore Therefore, one is divisible by p. Why? Because n minus p1 into p2 into p3 and so on pn is nothing but 1. So this n minus p1 into p2 into p3 and so on pn is being divisible by pa, so that 1 must be divisible by pa. In fact, this statement is wrong. 1 is divisible by pa. This statement is wrong, as we took pa as a prime. We discussed 1 is neither prime nor composite. So prime number cannot divide 1. So p prime number is not a factor of 1, which is contradiction. We got contradiction, which is contradiction. We arrive to the contradiction because as we assumed statement is wrong. So our statement what we took initially, that is wrong. So our assumption number of primes are finite is wrong. So our assumption number of primes are finite is wrong. So we can finally conclude number of primes are infinite. Therefore, number of primes are therefore given statement number of primes are infinite is true. Hence proved. So number of primes are infinite. There are infinitely prime numbers are present.